Hello and welcome back. Now we are discussing the next lifting machine, which is called as worm and worm wheel. Now, to many of you, the concept of a worm and a worm wheel is going to be quite new. I know that. And in some rare instance, some of you, if you have had some good background in actually seeing machines at work somehow, then you may be knowing about the concept of a worm and worm wheel. See, in English language, the worm, the word worm means kida. Okay. And there is a reason for calling one particular machine part, or rather naming it after a worm or kida. Let us see why. See, this is the arrangement of a worm and worm wheel mechanism which is used to lift this load W. Once again, this part is clear to you that this is a drum or a disc onto which a rope has been tied and you are pulling it downwards. So this is the effort part. So by applying the effort, you are rotating this drum, and when the drum is rotated, this shaft will also rotate. Now on this shaft, as you can see, there are screw thread like serrations made, and this part of a shaft is actually what is called as a worm. इसको कीड़ा कहते हैं. See, actually when this thing rotates, then the motion is almost like the motion of a worm. That means a worm actually moves very slowly on earth. Okay, एक कीड़ा जो है वो इस तरीके से धीरे धीरे मूव करता है. And the actual concept behind this particular arrangement is also to make the motion very slow like that of a worm. So now this is a two-dimensional image and not much would be clear to you. Worm and worm wheel. First of all, let us understand what that is. This part is called as the worm, and the gear that you see over here, this gear is meshing with the worm. If you see here, see the teeth of, I will just enlarge it a little. See, the teeth of the worm are going inside the gaps of the teeth of the gear. So these are meshing gears. This is called as meshing. Whenever you say that the gears are in mesh, that means one type of gear tooth is actually contacting with the other type of gear tooth. And when one is made to run in particular direction, then the other will also move along with it. So we are saying that the worm, this one, and the worm wheel. A worm wheel is nothing but a simple gear. Okay, a gear which enmeshes or meshes with a worm is called as a worm wheel or worm gear. Okay, so now they are in a mesh right now. They are meshing with each other. So what happens is when the shaft of the worm moves in a particular direction. Okay, so this is moving or rotating in this direction, this shaft. So what will it do is it will make the gear or the worm gear rotate in this direction. We will understand. I have prepared, or I rather I have downloaded few very interesting videos for you to look at, so that the concept of a worm and worm wheel will be perfectly clear to you. There will be no doubt left in your mind. But just to start with, I am saying that when this axle rotates in this direction, then the worm wheel will rotate in this direction. And there is a small pulley or a small disc which is rigidly connected to this worm gear. So if this gear rotates in this direction, this wheel will also rotate in this direction. And when this wheel rotates in this direction, this rope which is wound around this wheel will climb upwards and the load will be lifted. So this is the overall connection between worm and worm wheel by applying an external effort P. Now let us see how the arrangement here is. I'll just play this video and then explain it to you. See, this is the worm. Now you actually see how a worm is meshing with the teeth of the gear, and when you rotate the worm in a particular direction, how it makes the rotation of the gear or the worm wheel possible. So just have a good look at this video. This will actually explain, see how these teeth are meshing. Got it? So actually this worm is nothing but a screw like object. See, on the shaft the worm is, see, this is very clear here. Can you see? This is actually a screw like winding over a shaft. This is called as a worm. And when you rotate the screw like arrangement, the teeth of the screw are actually in mesh with the teeth of the gear. So when you start rotating the worm in one direction, it enables the rotation of the gear also. So this is the basic concept of a worm. This one is worm, this is worm wheel. Now, if this is understood, then let us go to another video. I will just show you what is happening in our experiment. Now see, this particular video gives a clear depiction of what we are trying to achieve over here. So this whole figure actually represents this experimental setup. The only difference that you will observe is that the worm and the pulley mechanism are attached at the top of the gear here in the figure. Whereas in this video, the attachment is the worm, and the pulley attachment is placed below the wheel. It does not make any difference whether you rotate the wheel from below or whether you rotate it from above. It does not make any difference. See, I have attached the image here also. So in as per the image that you are seeing here in your notes, you can simply take this complete shaft, pulley and worm attachment and attach it over here. See, the worm will come here, the shaft will go like this, and here your pulley will come. And on this pulley there are ropes tied, and this is how the effort is going. So this arrangement, if you take this arrangement out of here and put it at the top, this actually constitutes the arrangement seen over here in our actual image. But it does not make any difference. So let us see how the mechanism is enabled. See, first of all, let me explain the arrangement that is made here. The pulley is there. See the rope coming out from the front, and you see a small amount of load is attached over here. See, this is a very small amount of load, and this load is actually acting as the downward effort. So this small weight is acting as the effort which is pulling the pulley downwards, and now the pulley is going to rotate in this direction. When it rotates, this shaft will also rotate. When the shaft rotates, the worm will also rotate. And when the worm, which is actually in mesh with the teeth, it rotates, then this gear mechanism rotates in this direction. And now see that this pulley is attached rigidly to the main gear. So when the gear rotates in this direction, this pulley is also going to rotate in this direction at the same RPM. And when it is rotating, you see that the threads are now wound around this pulley. So when this pulley rotates in this direction, this thread will be pulled upwards, and this is your W, the overall weight that you are trying to lift. This will move upward. Now the most important thing to notice in all of this is that look at the effort. So many tiny pieces of weights are just put over here. This is your simple effort. So this P is so small that this small amount of weight is actually managing to pull so much heavy weight. See the weights that are attached over here, they are so big, at least 1 or 1.5 kg per block. So nearly 5 to 5.5 kg is being lifted with the help of this one, and you are applying so little effort. So this is actually how you gain the mechanical advantage. So I hope the mechanism is clear to you from this image. And now let us see the mechanism in actual working, because I have a video for this one also. Okay, this is the video. Let me just play it. See, this is the worm. It is in mesh with the gear. This tray, see, he is attaching more load. The load is becoming heavier now. Okay, and now let us skip to the part where the actual thing starts moving. Okay, now see, after the application of, I will see once again, see now, after the application of the load, he will apply a little bit more effort at the this dish, and see, small effort applied. Now this is rotating, the worm is rotating and the gear is rotating, and the load is being lifted slightly upwards. See, see, see how slowly this whole arrangement is moving. When the gear rotates, the pulley also rotates along with it at the same RPM. This is the arrangement. Now I hope that is clear. And now, before moving on to the development of the formula of velocity ratio. So again, the task in our hands right now is to find out an expression for velocity ratio. So we will develop the expression. If I pull this rope downwards, then I will get a displacement y for the effort. And I want to find out what will be the eventual climb, or by how much distance will the load climb upwards x. So the velocity ratio, then I can put it as the ratio of y upon x. This is what I am after. But in order to come to that derivation, you have to understand a lot of terminology of worm and worm gear before starting with the derivation. So in order to do that, first of all, let me show you some more videos that will explain the concept of how a worm is constructed. Okay, look at this video very carefully now. This is how a worm came into being. See, it is actually started with a gear template with a single tooth on it. एक गियर का ब्लॉक है, लेकिन एक ऐसा इमेजिनरी गियर आप मानिए जिसपे कि खूब सारे टीथ होने की बजाय यू सी देयर इज ओनली वन सिंगल टूथ. And if you see that the tooth is a tooth of a gear is actually constructed parallel to the axis of the shank itself, this main body itself. But now see how we can imaginarily twist this tooth to form what is called as a worm. See, the single tooth itself is made to wound around the body in the form of a spiral to form a complete worm. Now this is called as a single start worm. Single start worm means a worm which is constructed out of a single tooth. Now let us go to another video and see what is the meaning of a double start tooth. The concept is the same. See, we start instead of with one tooth, we start with two teeth. And again, just like in the previous case, we wind it around the overall diameter of the body to get a double start worm. And in this fashion, you can have a triple start worm, a four start worm, a five start worm, and so on. So theoretically, you can have as many number of starts for a worm. And the number of starts of a worm, whenever you hear that I have a double start worm, so you must remember that a double start worm means a worm which is constructed out of an imaginary gear which starts with only two teeth on it, and then you wind it along the diameter like a screw thread. Okay, so we will come back to this video and get more information out of it. But now look at this video. This video shows a comparison between single start worm and a double start worm. What is the difference between a single start worm and a double start worm? You see in this video, for every single rotation of the worm, only one tooth of the worm gear is moving. Did you see that? See, you can look at this part where the complete rotation is being noted, or you can look at here where the empty this part, when it comes up, you say one revolution is complete. See, start, end, start, end. So if you look at this particular tip of the worm, you can understand how one revolution of the worm is completed. Now please note, when one revolution of the worm gets completed, only one tooth of the gear actually rotates. But look at this part now. Now in this case, we have a double start worm. Now again, look at this particular tip of the worm, and this is start, stop, start, and again stop. So this is one revolution of the worm. And please note that in one revolution of a double start worm, two teeth of the gear are actually moving. So this comparison is just to explain to you that in the case of a single start worm, the speed of rotation is one tooth per revolution of the worm. So I can say, I will repeat myself once again, one tooth of the worm wheel will rotate when one complete revolution of the worm is enabled. And in the case of a double start worm, when one revolution of the worm is enabled, then two teeth would have moved on the gear or the worm wheel. So this is the concept of worm and worm wheel. So in other words, I can say that the worm comes with an additional concept of whether the worm is a single start worm or a double start worm, and theoretically you can simply go on adding number of starts, a triple start worm, and so on. Okay, so depending on how many starts the worm has, you simply go on adding single start, double start, triple start, and so on. And what is the significance of this single start, double start, triple start? This is start. That means it starts with a single tooth. This one starts with a set of two teeth. And this one, if you remember the video, then you have to imagine three teeth. Then triple start worm will start with three teeth. Okay. Now a single start worm will make only one tooth of gear move. So in one complete rotation, one revolution of the worm will cause the worm wheel to move only by one tooth. One revolution of a double start tooth or a double start worm will cause the attached gear to move by two teeth. So it's a very small movement. You see, how many teeth are there on a gear? A gear will have 1, 2, 3, 4, 5, 6, 7, 8, some 20 to 30 teeth will be there. So just imagine that the worm, this is the worm, see, a worm is a thin structure. This is the worm. When the worm rotates by one full revolution, the gear attached to it will move only this much. See, only this much angle will be moved. Why? Because this will be two teeth. It will move by a distance of two teeth only. And in the case of a single start one, the gear will move by only one teeth. And in the case of a three start or triple start worm, the gear will move by three teeth. This much revolution will be made possible. Three teeth will move together at a time. So if you want to increase the speed of the worm and worm wheel drive, you have to basically increase the number of starts on the worm. Otherwise, the speed will become very less. And actually, this mechanism, the mechanism of a worm and worm wheel, was designed by engineers for heavy speed reduction only. So these mechanisms are used for heavy speed reduction. But basically, you will learn about all these concepts in your later semesters. In this particular video, I just wanted to make you acquainted with the concept of a worm and a worm wheel. And what is the concept of single start and double start? Okay, now, even before we proceed further, I would like to give you some additional concepts about screw threads. See, a screw thread, which according to what we are studying right now, this is a screw thread. Okay, let me try to draw it in as good an image as possible. Your screw threads are like this. Okay, now when one rotation of the body of the screw is enabled, this screw can be considered as your worm also. Okay, as you have seen in your previous videos that I showed you, the worm actually is nothing but a, see, these are threads. See, these are the threads on a shaft. So if you have threads like this, in one revolution of the worm, what you get is a horizontal distance from one top of the thread to another adjacent top of the thread is made possible. Okay, this is called as the pitch of the thread or the pitch of the worm. It is denoted by small p, and this is the spelling. This is called as pitch. So what is the definition of a pitch? A pitch is the horizontal advancement of a screw thread or a worm when one complete revolution of the screw is enabled. Or if you rotate the screw by one single revolution, then a horizontal advance of p distance or the pitch is obtained. Okay. Sometimes, for the sake of simplicity, the pitch of a thread is also defined in a better way as the horizontal distance between two adjacent threads. Okay, so this is the definition of a pitch: the horizontal distance between two adjacent threads or the two adjacent singular threads of the screw. Now there is another thing called as the lead. Lead is actually the thing that I defined earlier. Okay, so I'm drawing this once again, and I will not go for a complete three-dimensional image. I will simply draw it like this. So now you know what is the meaning of this and all. So I will simply draw it like this. So I will say that since this is my first thread that is visible, and then there is empty shank, and then comes the next thread. So this is called as the pitch, the distance measured between two adjacent peaks. Okay. Now what is a lead? Now when I rotate the screw by one revolution, automatically the horizontal advancement will be equal to one pitch. Okay. So I will say that lead is equal to horizontal advancement for one rotation or one revolution, and pitch is equal to horizontal distance between two adjacent means sitting next to each other, between two adjacent threads. But what happens is, in the case of single start, in the case of single start threads, the lead and the pitch are exactly the same thing. See, lead is defined as the horizontal advancement for one revolution, but pitch has nothing to do with revolution. Okay, pitch can be simply observed by picking up the screw in your hands and you just look at it without rotating it. Just take a small scale and try to measure the distance between two adjacent peaks of the threads. So this is pitch. But in order to understand the concept of lead, you have to actually give the thread a rotation like this and then see by how much will be the horizontal advancement. And in the case of single start threads, the lead is always equal to the pitch. So whatever pitch you are observing here will be the actual horizontal advancement also, but that is for single start threads. And now look at this video once again. I will just pause it and now look at it. See, now there are, in this particular thread, there are two starts, or it is a double start thread. Let me show it. Yeah, see. The red one is one thread. So you see this red one is going like this, coming out, then going like this, coming out, then going like this. And parallel to it, the green thread is coming out, going like this, like this. It is spiraling out. Okay. Now I will just take an image of this so that I can explain the concept of see. Now I will explain the concept of a pitch and a lead. Let us take some other color. Okay, I think green will do. See, this is the single start. Right. For a single start thread, you can say that if I measure this horizontal distance, that means the distance between two adjacent threads, then this distance is my pitch. But once again, since it is a single start thread, see there is only one start. Okay. For a single start thread, the lead or the actual horizontal advancement is equal to the pitch only. But that is not the case of a double start thread. Now see, once again, if I look at the double start thread, I can say that what is the distance between adjacent threads. Adjacent threads, wherever I want to measure, will be measured like this. This is the first thread, let us say, and the thread sitting just next to it is this one. Although it belongs to the next start, but since iska padosi to yahi hai, so for the padosi, or what we call it in English as the adjacent tooth, this is the pitch. But what is the lead? When it meshes with the actual gear teeth, I already told you that the double start worm will make two teeth move together. Okay, so the lead is actually measured as the distance between one particular thread's start and its next particular occurrence. So you see, this red tooth is going like this. It is spiraling from the behind and then coming out like this. So if I just try to measure what is the horizontal distance between only the red part, then this is the actual lead. For a double start thread, the lead in that way becomes actual to twice the amount of pitch. So lead of a double start thread is twice of the pitch. Okay, because a double start thread in one rotation will enable this much distance of the worm to move in the forward or horizontal direction. So lead of a double start worm is equal to twice the pitch of the worm. Pitch remains the same. See, pitch is simply defined as the distance between two adjacent teeth. Okay, that is the definition of pitch. And lead is defined as the actual horizontal advancement when one rotation of the screw is enabled. So what will happen if I bring and show you a triple start thread? If there is another start thread getting started like this, it is going. If I bring another third thread, then your lead will become equal to 3 times the pitch. So this is the concept behind all the screw threads, the concept of lead, the concept of pitch. Now once again observe that even if I bring the third tooth over here and start a triple start thread from here, the pitch is going to remain the same. Pitch is defined as the distance between adjacent singular teeth. So this is P, this is also P. It does not matter which start it belongs to. But the pitch in this case will, sorry, the lead in this case will be one thread you start with, and then you try to find when is that same start coming to occur again. Then that complete distance will become equal to your lead. So lead is actually defined as the multiple of number of pitches, and that multiple is equal to number of starts. And that is what we are going to use in our definition. If you have a single start thread, then the number of starts is 1. If you have a double start thread on the worm, I am talking on the worm, okay? Number of starts is defined only for the worm, not for the gear. If I have a double start worm, then number of starts is 2. If I have a triple start worm, then number of starts is 3. In general, I can have an n start worm. So in that case, the number of starts, I will write it as small n. And that is what I have given in your notes. If the worm is n threaded, now whenever you see a term like this, n threaded, you just imagine that we are talking about n start. This is all that you have to understand. Okay. Now see, if I had not explained all this concept which is lying at the background, then this sentence would have made no sense to you. But now you know what is the meaning of n threaded. Okay, it means n start. So the number of starts could be 1. If it is a single start worm, then in your equations you put n equal to 1. If it is a double start worm, then in your equations you put n is equal to 2. If it is a triple start, then put n is equal to 3. In this way, you have to decide what will be placed at the location wherever you see small n. But anyway, we will come to the derivation right now. Now, since all this part is clear to you, how a worm is developed, what is a pitch, what is a lead, and how is actually a worm conceptualized, how is it developed. Okay, so these animations I think were very useful to you. Anyway, we will close all these videos. This is a single start thread, and now we will come back to the problem at hand. Now look here. I will remove this. Now let us make a comparison of the actual mechanism with that of the drawing. Okay. The drawing says that the wheel has a radius of r. So this horizontal distance is r. We could also give you a diameter. In that case, this whole distance would be the diameter. But in this particular derivation, they have taken radius. So let us go with radius. It does not matter much. So in this image, if I want to find out what is r or where it is shown, then I will say that this is the axis. So that means this distance is capital R, or the radius of the effort arm. Now let us go back to the image. This is connected with the shaft and this is the worm. The worm is in mesh with the worm wheel or the gear, and on the gear a pulley is attached. See, this pulley is this one. This is the pulley that is shown. So this pulley will always rotate in sync with the rotation of the gear. Okay, the gear is going to rotate like this when the effort comes down. P is applied here. This whole thing is P. Okay, P is applied downwards. So this rope will be pulled down. This pulley will rotate in this direction, and it will enable the rotation of the worm also in this direction. And when the worm rotates in this direction, the gear will rotate in this direction. And when the gear rotates, the pulley also rotates in the same direction. And when the pulley rotates in this direction, it will pull the rope upwards. And this is where your weight is attached. So this thing can be understood from the figure now. Okay. And now, small r is not the radius of the gear. The radius of the gear will be the mean diameter up to the teeth. That is not we are considering. We are considering the part where the rope of the load is circulated. This is where the rope of the load is looped around this pulley. So we are concerned with the radius of this attached pulley only. Or in other words, I can say that this, only this much is my small r. This is my radius. Okay. So this is capital R, this is small r. And now let us come back to this image. And now we are ready to do the derivation. Now again, some complications are there, but we will follow it up with as simple an explanation as possible. Let me remind you, in all this trouble that we are taking, the ultimate objective is to develop a relationship for velocity ratio. So I just want to find out that if I pull down this rope of effort by a distance of y, how much will be the up climb of this load x? That is all that I'm interested in. Okay. Now see, this is connected with the worm is connected with the gear is connected with the pulley, and the pulley is pulling the load upwards. So let us see, the relationship for y is very easy. How? Again, consider one revolution of the effort wheel. On one complete revolution of the effort wheel, the circumferential distance traveled by this will be 2 pi r. Since the radius is given, it is 2 pi r. If the complete diameter would have been given here, then the distance would have been pi d, as in some previous cases we have seen this also. So let us go with r, since r is given. So in one revolution of this wheel, the amount of distance by which this rope moves would be equal to 2 pi r. This is now very easy for you to understand because we have done earlier also. So can I say that this 2 pi r is nothing but my y? I am pulling down from here and 2 pi r rope has come down. So y is equal to 2 pi r when I make one revolution of the wheel. Now in one rotation of this wheel, this shaft will also undergo one rotation. And since the worm is carved out on this shaft itself, so I can say that the worm will also undergo one rotation or one revolution. And now let us say that this worm and the worm wheel arrangement is n number of starts. Not one start, not two start. I'm just saying that this is n start worm over here. Now, if I have an n start worm, then n number of teeth on this gear will move together. Okay. So if I say that for the sake of convenience, let us say it is a three start worm. So what will happen is for a three start worm, one, two, three, all these three teeth will move together. In other words, when one complete rotation of this worm is enabled, only this much part of the total gear will rotate in this direction. Only this much rotation is possible, not one complete revolution. Only that much part of a revolution which covers three teeth will be moved by the gear in this direction. Do you see? One revolution of worm, only a small revolution or small partial revolution for the gear. And only by that distance will this X rise up. So we have to find the relationship for this. This is not very difficult to find out. Let us go about it. This 2 pi r is y. Let us keep it here. We are concerned about how much will be this X. Okay. So this is an N start worm. So N teeth will move in one rotation. Now let us say that capital T is equal to total number of teeth on what? On the worm wheel. Let us say that T is total number of teeth on the worm wheel. You count all these teeth, 1, 2, 3, 4, 5, 6. So total number of teeth on the worm wheel is capital T. Let us say that. Okay. So if I ask you the question, forget about this worm and all this thing. If I take this gear separately outside, I am taking it out of the system, this gear, it has got T teeth. My question is, what will happen? How many teeth will move if I give it one complete revolution? In one complete revolution of this gear or the worm wheel, I can say that all the T teeth will have passed by or all the T teeth will move. Okay. Now, my next question is, if instead of moving all the T teeth, I say that I have only moved n number of teeth, only n number of teeth have moved, then the next question is, what is the fraction of one rotation that I have moved the wheel? इसको हिंदी में मैं समझाता हूं एक बार और ताकि आपको क्लियर हो जाए. भाई टी दांत अगर मैंने चला दिए तब मैं कहता हूं कि पूरे गियर का एक रोटेशन हो गया. लेकिन अगर पूरे टी टीथ चलाने की बजाय अगर मैं सिर्फ इसके तीन ही दांत आगे सरकाऊं तो कितना रेवोल्यूशन ये गियर घूमा. इसको समझने का एक तरीका ये है, ये देखो सिंपल तरीका आप भी अपने रफ में ऐसे कर सकते हैं. फॉर टी टीथ वन रेवोल्यूशन. ओके. फॉर वन टूथ 1 by t revolution. For n tooth, n by t revolution. This is a very simple technique to find how many revolutions will the wheel rotate if I make it move only by n number of teeth out of a total of t teeth. Once again, see how I have achieved this. If I rotate all t teeth, then I say one revolution is completed for this wheel. If I say only one tooth has moved, then that means 1 by T amount of revolution has covered. If I say I have covered n number of teeth, then the number of revolutions will be n multiplied by 1 upon t. ये ऐसी बात हो गई, एक दांत के लिए इतना है तो n दांतों के लिए कितना होगा, तो n से मल्टीप्लाई कर दिया, n by t revolution. Okay, so eventually what I can say, I will remove all this. I am going back to one revolution of this disk. When it is rotated by one revolution, the worm will also rotate by one revolution. But in one revolution of the worm, only n number of teeth of the gear are moving. Only n number of teeth are moving. But what is the implication of n number of teeth moving on the gear in terms of revolution? When n teeth move on the gear, that means the gear has moved by n by t revolutions, which was just made clear to you right now. Okay. So I will say that when the worm moves by one revolution, the worm wheel moves by n by t revolution. And if the worm wheel is moving by n by t revolution, what do you think will be the revolution of this disc which is attached to the worm? Since it is rigidly attached to the worm, it is something like this, the attachment. Okay, I will just try to show you a small image of how it is attached. This is how it is attached. See, this is the disc over which the load is attached, and this is your gear. So when the gear rotates by any number of revolution, this disc will also rotate by the same number of revolutions. Okay, the image is not very clear because it's a complicated image. It will take a lot of time to draw a neat image, but I hope you get the gist of this situation. So what I'm saying is, when this gear rotates by n by t revolutions, how many revolutions would have completed by the disc attached to it? Since this is forced to move along with the gear only, this will also move by n by t revolutions. Okay. Now, this disc is having a radius of small r. So, if the disc was allowed to complete one revolution, then the total amount of rope that it would have circumferentially pulled upwards would have been equal to 2 pi small r. मतलब अगर इस डिस्क को मैं एक पूरा रोटेशन देता तो ये एक पूरे सर्क्यूमफरेंस के अलोंग की जो डिस्टेंस है यानी कि 2 पाई स्मॉल आर उतना रोप ऊपर खींच लेता, लेकिन ये डिस्क कितना घूमा? क्या ये एक रेवोल्यूशन घूमा? क्या नहीं, ये सिर्फ n बाई टी रेवोल्यूशन घूमा। तो एक रेवोल्यूशन पे 2 पाई आर रोप ऊपर खींचता है, तो n बाई टी रेवोल्यूशन पे कितना रोप ऊपर खींचेगा? द अमाउंट ऑफ रोप pulled upward by this disk in n by t revolutions will be simply equal to n by t multiplied by 2 pi r. This is the amount of rope actually pulled upwards by this disc, or in other words, this is your x. इतने ही अमाउंट से आपका लोड ऊपर खींचेगा. तो ये पूरा कनेक्शन आपने बनाया. आई होप दिस वाज अ लिटिल बिट कॉम्प्लिकेटेड, बट द बुक्स डू नॉट गिव एनीथिंग बियॉन्ड दिस मच. देखो आपके डीपी शर्मा से उठाया हुआ इसका वो प्रूफ है या इसका डेरिवेशन है, लेकिन ये सिर्फ इतनी सी बात में कहानी खत्म कर देता है. लेकिन इसके पीछे देखो कितनी सारी नॉलेज थी आपकी. अगर ये किताब से अगर आप पढ़ के सिर्फ इतना कर लेते तो आपके पास रटने के अलावा कोई ऑप्शन नहीं रहता. But I hope I have taken a lot of effort with the videos, with drawings, with images. I sincerely hope that all the concept is clear to you. But let me again remind you, when you write the derivation in your exams, then you have to write this much only. ये पूरी कहानियां जो मैंने आपको समझाई है, ये इसलिए समझाई है क्योंकि एज एन इंजीनियर यू आर सपोज टू नो ऑल दिस थिंग. सिर्फ एक रट्टाफिकेशन करके क्लास में नहीं जाने का है, एग्जाम में नहीं जाने का है, और आपके फ्यूचर के लिए भी आप सिर्फ ढोंगी इंजीनियर बने रह जाओगे अगर ये सब चीजें सिर्फ रट के पास हो गए तो. So you can do a good ratification of all this, and you will never know what is the actual concept behind a worm, what is the concept of a single start, pitch किसको कहते हैं, lead किसको कहते हैं, और lead के बढ़ने से आपकी स्पीड ऑफ वर्म और वर्म गियर को कैसे इफेक्ट होता है, और इनके कनेक्शन का क्या लॉजिक है. ये पूरा लॉजिक आपको अब समझ में आ गया है. मैंने ये समझा दिया है, लेकिन आपको एग्जामिनेशन में इतनी सी बात से ज्यादा नहीं लिखना है. प्लीज मेक इट अ पॉइंट, क्योंकि आप लोग इससे ज्यादा लिखोगे तो आपका बहुत टाइम वेस्ट होगा. ठीक है. सो हैविंग सेड दिस, कम बैक टू आवर प्रॉब्लम एट हैंड. आपको y की वैल्यू मिल गई थी, अब आपको x की वैल्यू भी मिल गई है. द अमाउंट ऑफ डिस्टेंस बाय विच द लोड मूव्स अपवर्ड्स. So the simple definition of velocity ratio is y upon x, and that will be simply the ratio of 2 pi r divided by n by t 2 pi small r. तो यही चीज यहां पर ले रखिए. ये देखिए 2 pi r into n by t, ये चीज यहां पर x के तौर पे रख दी. दिस इज योर x, और 2 pi capital R, दिस इज योर y. ठीक है. अब इसको रीअरेंज कर लो. 2 pi and 2 pi cancel out, t will go upwards, so it is simply r capital T upon small n into r. अब इसको एक बार रिवाइज करो, ये क्या चीज है. कैपिटल R is the radius of the effort wheel. Capital T is the total number of teeth on the worm wheel. Small n is the number of starts of threads on the worm, and small r is the radius of the pulley attached to the worm wheel. It has got nothing to do with the worm wheel. It is this disc or drum is attached to the worm wheel. So it is the radius of the worm wheel. Now instead of radiuses, if your problem gives you the diameters, then all you have to do is replace the capital R with capital D diameter. T will remain the same, n will remain the same, and the small radius of the disk will be replaced by the diameter of the disk. Because eventually what is R? R is capital D by 2, and what is small r? It is small t by 2. So this factor of half on both sides, above and below the fraction, will get cancelled out. So it does not matter much कि आपको रेडियस दे रखा है कि डायमीटर दे रखा है. फॉर्मूला यही रहेगा, r की जगह d लगा देना, और अगर डायमीटर दे रखा है तो बस यही फॉर्मूला है. This is the formula for velocity ratio. And once again, if you see, mechanical advantage is given as the same thing. Efficiency is mechanical advantage upon velocity ratio. But again, you don't have to remember this part. This can be automatically developed by you. Efficiency का formula आपको develop करना आना चाहिए, लेकिन वो तो mechanical advantage by velocity ratio से मिल जाएगा आपको. This is the thing that you have to remember. Okay. Now, what I want you to do is, I'm not even mentioning which problem concerns your this worm and worm wheel. Go to the solved problem sets 8.1 to 8.11. Go through. You have to go through all these problems. ठीक है. RTU में आपसे derivation ही नहीं, न्यूमेरिकल्स भी पूछ सकते हैं. Go to page 343, one by one browse through all the examples and find out which problem or which problems, it may be more than one, I am not very sure, अभी मेरे को याद नहीं है, which problems related are related with the worm and worm wheel, और इसके फॉर्मूले अप्लाई करने की कोशिश करो और अपने आप सॉल्व करने की कोशिश करो. The numericals that will come from this lifting machines are very simple. You don't have to worry about the numericals. You just have to remember the velocity ratio for all these. और एक बार आप इन सारी चीजों को पढ़ लोगे तो मैंने आपके नोट्स के अंदर ही ये पूरा कंपाइलेशन भी दे रखा है. फिर एंड में जाके आपको याद तो करने ही पड़ेंगे सबके वेलोसिटी रेशियो. ये देखो, वेस्टर्न्स डिफरेंट, पुली व्हील एंड डिफरेंशियल, सिंपल व्हील, वर्म एंड वर्म व्हील, ये सारे फॉर्मूले यहाँ पर समराइज कर रखे हैं. So for your preparation of exams, you can simply go through these individual formulae and develop your concept of the derivations later on according to your convenience. Okay, so this covers one another important aspect of not only your engineering mechanics but your engineering career. क्योंकि engineering में pulleys, gears की meshing, worms, worm wheels, threads, थ्रेड की पिच, थ्रेड की लीड, ये सारी इतनी इंपॉर्टेंट कॉन्सेप्ट्स हैं कि ये जिंदगी भर आपको पता होनी चाहिए, सिर्फ इंजीनियरिंग मैकेनिक्स के लिए ही नहीं. एंड आई होप आई हैव डन अ लिटिल बिट जस्टिस इन एक्सप्लेनिंग ऑल दीज थिंग्स टू यू, बट द ओनली बेनिफिट विल बी accrued when you remember and inculcate this learning in your life. ठीक है, तो इसको आज पढ़ के देख करके भूलना नहीं है, इन कॉन्सेप्ट्स को समझ के मन में रखना भी है. Having said that, best of luck, and I will stop this lecture here. Thank you.